Because we have done this in class. Say something, otherwise. Yes. Do you know some? Anybody knows that what is random variable? In class, we are talking again and again this random variable. Yes. I've given very simple example. I had given very simple example in the class. Anybody knows what is random variable is? Yes. Akanksha, can you tell me what is random variable? Akanksha.
Yes, sir.
What is random variable? Hmm?
So is random variable a variable with whose value is unknown?
सब लोग ऐसे क्यों डेफिनेशन देते हैं, मेरे को समझ में नहीं आता। ये पूरी मतलब पूरी दुनिया जहाँ घूम के आ गया मैं, ये सभी के सभी स्टूडेंट यही आंसर देते हैं। और क्या है, क्या क्या समझते हो? बस इतना ही पता है रैंडम वेरिएबल के बारे में कि इसका वैल्यू अननोन है, इसलिए रैंडम वेरिएबल बोल रहे हैं इसको।
Sir, the output depends on random case.
Can you give an example me? Can you give me an example so that I can correlate your definition? Yes, yes, Akanksha. मेरे को ये समझना है कि आपको
Sir,
आता
I
कितना
don't know if it is correct or not, but
हाँ,
if we toss a coin, then heads and tails, those two are.
possible outcome. Yes.
Yes, sir.
Then is it random variable?
So, sir, x will have heads or tails value, so that x is right.
और रैंडम वेरिएबल के पास डोमेन रहेगा कि उसके वैल्यूज क्या क्या रह सकते हैं, बट हम लोग ये डिटरमाइन नहीं कर सकते उसका स्पेसिफिक वैल्यू क्या रहेगा एट अ पॉइंट ऑफ टाइम।
ठीक है, वो सब ठीक है, बट क्या एग्जैक्टली क्या इंटरप्रेट कर रहे हो इसको? जैसे ये बोल रही है हेड एंड टेल आ रहा है, तो उसको वो रैंडम वेरिएबल बोल रही है।
सर वो हेड एंड टेल तो उसका डोमेन ऑफ वैल्यूज है ना, रेंज ऑफ वैल्यूज है, तो
डोमेन और
हेड एंड
रेंज।
टेल्स में से कोई भी वैल्यू रह सकता है, इसलिए उसको रैंडम वेरिएबल करके डिनोट करेंगे कि जब कॉइन टॉस करेंगे उसका वैल्यू क्या रहेगा, इट कैन बी इधर हेड्स और इधर टेल्स। तो
ओके, ठीक है, ठीक है, ओके। आई हैव गिवन आई हैड गिवन दिस एग्जांपल इन क्लास आल्सो, राइट? अभी इसके बाद मैं इसको रिपीट नहीं करूंगा। व्हाट इज रैंडम वेरिएबल? सो you just see this and you will find that what is random variable by yourself only. So right, this is so the very first thing is what you need to understand, what is the probability. If you know probability, then only you will understand random variable. And once you know these two things, you will know random process. Our unit is random process, right? And I am repeating it again and again. In your class itself, I have spent 3 to 4 hours in describing this probability and random variable. Go and check the videos. What is random variable? You will find it's very easy. I don't know why you have not got that point till now. So I will not start with probability. I will start with random variable now. So when you say random variable, suppose you toss a coin, like she said, Akanksha. toss a coin. So when you toss a coin, you list the possible outcomes. So tossing a coin is just an experiment. So we are doing an experiment, and that experiment is tossing a coin. So you first you list out all the possible outcomes. And this list, in more formal, it is called a set of all possible outcomes. What we call it? What is the what we call this in one word, or set of all the possible outcomes? What do you call it? Have you talked about? Have you understand this sample space? Yes. What is sample space? What is sample space? I've written everything here.
So range of all possible values that that a function can have.
Okay. Don't say like values, right? Say specifically, it's a set of all the possible outcomes which may happen during the experiment, right? Getting my point?
Yes,
So
sir.
sample space, we denote it by capital letter omega. Please note this notation. This is the notation that we are going to call it for sample space. So it's a set. So when you say set, it's a set. So set we write in curly bracket. Either I can get head, I can get tail. So this and this are nothing but outcomes. So these are called as outcomes, or you can call it sample points. And this is called sample space. This is called sample space. So when you say sample space, it contains outcomes, it contains sample points. We denote it by small omega. This is small omega, this is capital letter. So sample space we denote it by capital letter. This is a set in your mathematical term, and this is small letter. Small omega, capital omega. So when you do an experiment, tossing a coin, right? Let me go back here and write here only. So this is the notation that we use. So we toss a coin. So we get sample space, sample, head, and tail. This is set of all the possible outcomes, or you can say that this is the listing of all the possible outcomes. So this one, each one of is sample point, or you may call it outcome. You may order them like omega 1 and omega 2. So this is one outcome, this is second outcome, like that. Now this is okay, this is sample space, but next thing is what I'm going to do with this kind of tossing. So you have two persons, Ram, Sahil. Ram and Sahil, they are friends. Ram says to Sahil, let's play a game. Sahil says, which game? Ram says that let's toss a coin, flip a coin, and let's bet something on rupees, money, right? So Sahil says, no, I'm not going to play. So Ram says, please play. So Sahil says, why? So Ram says that if head comes, Ram is going to pay 4 rupees to Sahil. If tail comes, Ram says, you give me 2 rupees. Sahil says, that's fine. If 4 rupees I will earn, then I will play the game. So he says, this is Ram and this is Sahil. Just try to understand what is this. So with respect to Ram, if you connect these two things, head means -4, tail means 2. This is sample space, each one of this outcome. This is random variable, each one of this is a numerical value. So these are sample points, or if you want to call it outcomes. This is sample space. This is called random variable. This is called numerical value, or you may call it sample value. Now let's see how to define random variable now. So let's take random variable as a block, right? So this is random variable. This is random variable. This is random variable denoted by capital X, and I am showing this is a function, so it's a function of outcome. So in this case we have head and tail. This is my sample space, and here I have numbers like -4, 2. This is my real values, right? When head comes, Ram will give 4 rupees. If tail comes, Ram will receive 2 rupees. This is small omega, this is X, right? So what is this? When you say X omega equal to H, it is nothing but X1 equal to -4. When you say X omega equal to tail, you say this is X2, which is 2. So this is I am saying X1, this is saying I am X2. Or some people don't write this X1 and X2. They say that small x takes -4, small x takes +2. What you see here is random variable. What is random variable? Can you tell me what is random variable now? Random variable is a mapping from sample space to a real line, because here we are going to talk about real random variable, not complex random variable. So you can define random variable as a mapping from sample space to real line, or you can define random variable is a function of which maps, which assigns each outcome, which is small omega, in the sample space capital omega to a real value small x. किसी को डाउट है इस पे? Any doubt in this? Ask the doubts, otherwise it will not be clear. Any doubt? Any doubt in this? Say yes or no. Any doubt in this? So ये definition अभी तक से याद क्यों नहीं हुआ? Is it difficult? Is it difficult? बोलिए.
नहीं है सर.
क्यों नहीं समझ में आता हमको इतना? हम ये बचपन से पढ़ते आ रहे हैं ना, ये सिग्नल सिस्टम में पढ़ा आपने, ये सब जगह पढ़ रहे हैं आप. सो रैंडम वेरिएबल जस्ट फंक्शन, एंड फंक्शन का काम क्या है? इसका इनपुट आर्गुमेंट होगा, इसका आउटपुट होगा. इसका इनपुट आर्गुमेंट आउटकम है, इसका इनपुट आर्गुमेंट आउटकम है, इसका आउटपुट आर्गुमेंट वैल्यू है, विच यू कॉल इट सैंपल वैल्यू और न्यूमेरिकल वैल्यू. सैंपल स्पेस तो सैंपल पॉइंट्स, वैल्यू तो सैंपल वैल्यू, सैंपल पॉइंट्स को सैंपल वैल्यू मैप करना है. सो रैंडम वेरिएबल कुछ नहीं करने वाला है. रैंडम वेरिएबल चुपचाप एक आउटकम लेने वाला है और एक वैल्यू असाइन करने वाला है. दूसरा आउटकम लिया, दूसरा वैल्यू असाइन किया. In general, if you ask me that random variable here, so notation, this is very, very important. People get confused always because they don't know the notations. I've just written two notation for two things. Sample space, we denote it by capital omega. It's a set. Sample points, some people call it outcome. We denote it by small omega. So this is the notation. Second notation I have used was random variable. So they denote it by capital X, but you can denote it by x of omega because it's a function of omega. So people don't like to write this omega because they say that one, since this is a random variable, so they know that it has to be function of outcome in any experiment. So they don't write it. So they write just capital X. They don't write omega. I'm going to use this notation, but it does not mean that when it does not depend on any independent variable. It depends on the outcome. It depends on the outcome. So it's a function, and the numerical value that it will take, or you may call it sample value, I'm going to denote it by small x. This is small x. So this is the notation. These notations are, this notation you can use. You want to take carry the, you want to carry this omega, you can carry this omega. If you don't want to write this, you don't write. This is implicit. When you write capital X, if you say this is a random variable, then it is implicit that it's a function of outcome, because no random variable can be all the random variables, they always take outcome and they assign one value, one numerical value. So why we do this? Because numerical values are easy to work with. Outcome can be word like this. Here outcome is like head, tail. In some experiment, this can be sentence. Sentence 1, sentence 2. So this may be outcome. In some experiment, they are numbers 1, 2, 3, 4, 5, 6. Like when you roll a die, what is the sample space? 1, 2, 3, 4, 5, 6. This is sample space. So sample space, there is no restriction on sample space. Sample space can be word like head and tail. It can be sentence 1, sentence 2. It can be numbers also. But random variable will always be represented in terms of value. It cannot be sentence. It cannot be head and tail. It has to be some number, right? So doing the experiment, flipping the coin, what are I supposed to do with this head? Coin toss kiya, head hai, tail hai. What will I will do with that? I will assign some number to this, right? So this kind of analysis can be done by using this random variable analysis. This is very important. Random variable, it's not a variable, it's basically a function. We know beforehand what are the possible outcomes, but we don't know exactly which outcome is going to come. So random is nothing like it's a completely random, right? Random is something we know possibilities, but we don't know exactly which possibilities is a possible thing is going to happen at the end of experiment. So this is called random variable. One more thing, since random variable, I said random variable, a function, so it should obey all the properties of function, but it's a special function. A special function means what? Function also, function का domain जो है, it can be sentence, it can be word, it can be anything, but जो function का range है, it is always going to be a value. It is always going to be real value, real number. So it's a mapping from sample space to real line, right? So x omega, it's a function which maps sample space to a value, right? So its input argument can be value, its input argument can be head and tail, its input argument can be sentences, but its output has to be a real value, a value plus minus anything. It can be floating value, it can be anything, but it has to be real value. Now, this is the one thing. So we said this is a function. Second thing is what? It can be one-to-one function, like in head and tail. It can be many-to-one function, but it cannot be one-to-many function. It cannot be one-to-many function. Let me give you an example of one-to-many function. If you write root 2, is it one-to-many or many-to-one? Sorry, when you write this, sorry, when you write y equal to x square, so when you find x equal to root y, so it can be plus minus, right? So you can see that one, it cannot be one-to-many function. The random variable cannot be one-to-many. What I mean by that, suppose you roll a die. Or let me give it this example only. Why it cannot be one-to-one, one-to-many function. We cannot assign two numbers to head. हेड का एक आउटकम एक ही नंबर को रिप्रेजेंट करना चाहिए. You cannot assign 2 or 3 numbers to tell, right? But it can be other way. It can be many to one. Like when you roll a dice, you get 1, 2, 3, 4, 5, 6. So this is sample space. This is sample space. Each one of these outcome. When you pass it through the random variable, it will produce a number, right? Again, Ram and Sahil. Ram says, even number comes, you give me 4 rupees. Whenever even number comes, even number means what? 2, 4, 6. Right? When 2, 4, 6 will come, Ram will get 2 rupees. So this 2, 4, and 6 will be 2 rupees. Many to one. He says that if 1 and 3 will come, Ram will give 4 rupees to Sahil. So this will be minus 4. But when 5 comes, he will say, we will again roll the die. We will say this is 5. We will discard that experiment. We will roll the die again. So you may call it no win, no lose, 0 rupees. So if 5 will come on that dice, I will say, you don't give me any rupees. I don't give you any rupees. So that is 0 with respect to Ram. So you can see this is many to one. So if you see this 2, 4, 6, they got mapped to 2. If you see this 1 and 3, they got mapped to minus 4. 5 got mapped to 0 rupees. But it cannot happen that one outcome will give you 2 values. Is this clear? Say yes or no, right? So we'll move forward. It's possible. Any doubt in this?
No,
Any
sir.
doubt? Okay. So now let's talk about random process. Once you understand random variable, it becomes very easy to understand random process. We call it random signal as a communication engineer. We call it random signal. Mathematician like to say this is a stochastic process. We can okay with the random process. Now let's see the random process. It is extension of random variable to include time. If you see this picture, this head and tail, it does not depend on the time. On which day you are playing, they are playing with the same thing. Head minus 4, tail 2. Head minus 4, tail 2. Not dependency on time. But what if random variable is going to be a function of time? So that is a question that will be answered by what? Random process. What if a random variable is also a function of time t? So random variable, we know that when it's a function of outcome, but what if this random variable is also a function of time? Then we call that process, that thing as what? random process. Let me give you the same example and you will find the answer. What is random process? So again, let's flip a coin again. Let's flip a coin. There are two outcomes, head, tail. This is sample space. Right. Now, you will take this outcome into that one and Ram says, let me draw that line also here. So let me draw it somewhat bigger. So this is head, this is tail, and suppose we have the situation like this. Now this is a function of time. Right? Let's say Ram says morning they are playing, right? Let's say at time t1 they are playing. Ram says head comes, I will give you 4 rupees. So this will be what? Somewhere minus 4 will come here. And if tail comes, you give me 2 rupees. So somewhere it is 2 rupees. This is just a random variable if you see, right? So this is t1. They play with they play the game. Ram win. He got 2 rupees. Okay. Sahil wants to take revenge, so he wants to play that game again. So he plays that game again. So at t2, they decide the same money earning like at t1. So minus 4 again and minus 2 again, plus 2 again. So this is t2. Ram again win the game, right? He again wins the game. Sahil says, I am not going to play now. Ram says, why are you not going to play? Because Ram is, anyway, he's winning, right? He got 4 rupees. So Ram says, play the game. This time, if head comes, I will give you 4 rupees. And if tail comes, you don't give me anything, right? So that is 0 rupees. You don't give me anything, 0 rupees, right? Then Sahil again lose the game, but he did not lose the money because this is the money that you don't have to worry about, right? Correct. Next time Ram says this is going to be unfair. Let's play with what some money. Also, you give me money. So this time he said that when at t4, he said that if head comes, I will give you 6 rupees. Somewhere 6. And if tail comes, you give me 1 rupees only. So this is at t4. You give me 1 rupees. So somewhere here it is 1 rupees. Right? Sahil win the game. This is minus 6, right? Sahil won the game at this time t4. Sahil is happy, right? They play again. Ram says, no, now this time we will play with the same money, right? So you give me 2 rupees or I will give you 2 rupees, no matter what. So t5, and now this time it is what? 2 rupees. 2-2, right? Lose, win, 2-2. They play the game, and sometimes this Ram says at t6 time. Now let's change our head and tail. If head comes, you give me. If tail comes, I give you. If head comes, you give me 3 rupees. If tel comes, I will give you 3 rupees. So if tel comes, Ram will give Sahil to 3 rupees. What do you see here? What do you see here? Now the random variable is a function of time. Both are plotted with respect to time t. In the same way that you can see, this is each outcome at t1 head minus 4, tel 2. At t2 head is minus 4, but tel is 2. At t3 head is minus 4, tel is 0. At t4 time head is minus 6, tel is 1. So every time you see at the time, this random variable is changing its values, but they are coming from the same sample space, no matter what, right? Is this point clear? So in the actual practice, it is called as discrete time random process, because you are observing the process at a specific time. But you may have the situation like what? It may be continuous function. It may be continuous, maybe like this. It may go like this. It may go like this. In the real situation, you will get always continuous time random process. Maybe like this. I don't know. It may be like this. So what do you find here? Is this a value now? पहले ये value था, अभी ये value है क्या? Is it a value now? Yes. Is it a little x?
No, sir.
What is this? Can I write this as a x of t? Can I write this as x of t?
Yes, sir.
So let me write this x1t. So can I write it like x2t? Yes, I can write x2t. Now you see that each outcome you take and assign a waveform. Head assigned to a waveform. You take tel and assign a waveform. So can I define random process now? Can I define random process? How you can define random process now? Just go back to random variable definition. Can I define random process? Random variable is a function of omega only, which maps assigns each outcome omega into sample space to the real value x. But random process is what? What is random process? Can you define random process? So random process is a function again. Function of what? Omega? Yes or no? Is it a function of omega or not? Say something.
Yes, sir.
It's a function of omega as well as what? Time?
Time.
Random variable was only function of omega, but now it's function of time also, which maps or which assigns each outcome omega in the sample space capital omega. Now it's not it's a value, but it's a function of time. So we call it to a waveform. You may call it waveform. वहां पे आप सैंपल वैल्यू बोल रहे थे, यहाँ पे क्या बोलना चाहिए मेरे को? सैंपल time function. So people generally call it sample function, or they call it only time function, which you can write as small x of t. So this is the idea of random process. In book they may write it in different words, but their meaning is exactly same that I have described now. Anytime you forget, you just create two person, Ram and Sahil, and just do that thing. You'll get the answer. So this is a random process. So random process, let me write this as a random process. It has to be denoted by capital X It's a function of t as well as omega. It will take omega as an input. Let me take that same thing as h t. Let me call it omega 1. Let me call it omega 2. This is my sample space. And now it will give me what? Either x1t or x2t. x1t or x2t, right? So this is the meaning of random process. It takes outcome, but it's a values. It gives you not a value. It gives you just time waveform or function. So this is you're calling it what? Time function or waveform. So head this, tail this. This is also a function, but this function is giving you another function of time, right? I hope this makes sense. Have you got this point? What is random process? Yes?
Yes, sir.
So what is the notation? Again, this notation is very, very important. Let me go back to sample space again. Sample space, omega. Sample points, head and tail, their outcome. It's a small omega. Random variable, what we denoted? Remember? Capital X omega, but we would like to use capital X. What is the numerical value or the sample value? That is small x. Numerical value or sample value. Now comes to this random process. Random process, capital X, function of t and omega, sample function or time function or waveform, you denoted by small xt. People again, they don't want to write omega there. They simply write x of t because they said that when since this is random process means it has to be a function of outcome. I don't have to explicitly mention that it's a function of omega, but here I have to mention this. It should be a function of time. Since this is a function of time, then I have to mention this as a function of time because this is a random variable when I don't write t there. When I write t, then I am saying that when this is a function of time. So it's not a random variable, but it's a random variable as a function of time. So that what I'm calling is what? Random process. So this entire thing is called as random process. This entire thing is called as random process. Okay, when you fix time, what do you get? When you fix the time, what you will get? When you fix the time, what you will get? Suppose you fix the time at t equal to t1. What do you get? Means when you sample the random process, sample, no? We are taking samples of random process. So when I sample the random process or when I fix the time, what I get? When I fix the time, what I get? At t equal to t1.
Real value.
Huh?
Real value.
Is it real value or numerical random variable? When you fix time, what do you get? H maps to -4, tail maps to 2. So this is what random variable, no? It's not a numerical value. These are the two numerical values taken by the random variables now, right? I'm not fixing the head. When I fix head and time both, then I will get numerical value. I'm not fixing the omega. I'm fixing only what? Time, t1. Is this point clear? Is this point clear?
Yes, sir.
So when you fix the time, what do you get? Because this random process is a function of time as well as omega. So fix the time. Fix the time means what? Take the specific value of any time. T is a variable. It can take from -infinity to +infinity second. But when you fix the time, it means fixing it to 2 second, 3 second, t1, t2 like that. So let's say fix it to t to t1. What do you get? Random process, t you fixed to t1 and omega is just a variable. It can be the any outcome from the sample space. So again, we don't want to write this omega. People started writing xt1. sometimes they write it like x suffix t1. This t1 is something what? This t1 is something what? Random variable. So when you fix the time, random process becomes just a random variable. Let's fix at some other time instead. Let's say t equal to t2. Again, they don't want to write this omega. They write only what? xt2. So they write like this xt2. This is another random variable. So this is a random variable. When you sample random process at t equal to t1, this is another random variable that you get when you sample the process at t equal to t2 vertically, right? When you fix time, you get vertical things. What is vertical things? Second, we take this t3, suppose. So let's take t3. t3. This is what the random variable x t1. This is a random variable x t3. So whenever you fix time, you get one random variable. If it is continuous time signal going from minus infinity to plus infinity, there are infinite random variables in a single random process. So this is what the meaning to that. So can I define my random process? This is my definition number 2. If you want to say the first was the definition number 1, then I will say this is definition number 2. Random process is a collection of all such random variables, maybe infinite random variables, indexed by time. This is important. When you sample the random process, you get a random variable. What if you fix the time? If you have fixed the time, what if you fix the omega? Fix the outcome. What do you get? When you fix the outcome, what do you get? Let's say omega equal to head or tail. Let's say omega 1 head. What do you get? T is the random variable. T is the variable now. It's still, but now omega equal to, you fix it to omega 1. What do you get? When you fix omega equal to omega 1, what do you get? What do you get? What do you get? Don't fix time now. When you fix omega, yes, when you fix omega, where to go after random process? Random process will give you what? When I say outcome is head, what you will say about random process?
रियल वैल्यू
वैल्यू कहाँ से आ गया? फिर से रियल वैल्यू आ गया आपका। ये डायरेक्शन दिया है मैंने, देखो यहाँ पे, when you fix head, what do you say random process is? What is this? वेव फॉर्म। अरे इतना सिंपल है यार, इसमें क्यों इतना रॉकेट साइंस जैसा दिमाग लगा रहे हो? हेड मतलब वेव फॉर्म, टेल मतलब एक वेव फॉर्म। तो जैसे ही आप बोलोगे हेड आया, आई विल से दिस इज x1t, रैंडम प्रोसेस इज x1t। व्हेन यू से टेल, आई विल से दिस रैंडम प्रोसेस इज x2t। इज इट नॉट लाइक दैट? व्हेन यू फिक्स टाइम, don't fix omega, you get 2 values in this case because there are 2 outcomes, maybe 5 outcomes, you may have different thing. Are you getting my point? Yes or no? You just see this t1, ये वही था जो random variable हमने ऐसे define किया था, h मतलब -4 rupees, tel मतलब 2 rupees when you fix the time. Yes or no? Yes or no? अरे बोलो भाई।
Yes, sir.
में आया, समझ में आया ना? Yes or no?
Yes, sir.
So when you fix, because we are saying this random process is a function of time as well as omega. So when you fix omega, omega 1 leads to x1t, omega 2 leads to x2t. Value बोलने से value is not a function, no, it's not a function of time. Value means it's a constant value. So when you fix omega, you get x1t. When you fix omega equal to omega 2, that is 10, you get x2t. So when you fix omega, you get waveform. And when you fix 2, you get another waveform or sample function. सैंपल पॉइंट से सैंपल वैल्यू होता है, सैंपल वैल्यू से सैंपल फंक्शन होता है. सैंपल स्पेस में आउटकम्स होते हैं, हर आउटकम को सैंपल पॉइंट बोलते हैं. रैंडम वेरिएबल हर सैंपल पॉइंट को लेके एक वैल्यू असाइन करता है, उसको सैंपल वैल्यू बोलते हैं. रैंडम प्रोसेस हर आउटकम को लेके एक सैंपल एक वेव फॉर्म क्रिएट करता है, जिसको अपन सैंपल फंक्शन बोलते हैं. So this is what sample function. When you get this one, when you fix your omega to omega 1, when you fix omega to omega 2, you'll get this x2t. So can I write my definition number 3? How will I define? How I've defined here, random process is a collection of all such random variables, right? So when you fix outcome, you get waveform, and random process is going to be a collection of all such बोलिए, random process is a collection. Some people used to say this is ensemble of all such what? All such what? Sample waveform or sample functions. This is definition number 3. What if you fix time and omega both? Fix time and omega both. What do you get? When you fix time and omega both, let's say fix time as t2. Let's fix omega equal to omega 2, that is 10. So you are fixing time to t2, omega 2, omega 2. What do you get? t को फिक्स करते हैं पहले अपन. Let's fix t. t को t2 किया है हमने. So I am in this world. When I fix t equal to t2, so this is t2 को t equal to t2 किया, मतलब I am observing these two values. When I fix omega 2, then t equal to t2, omega equal to 10. What this value represent? Where I will go? अरे ये इतना बड़ा डायग्राम दिया हुआ है, इसमें बताओ ना. t को फिक्स किया t2 पे, ओमेगा को फिक्स किया t10 पे, क्या मिलेगा मेरे को? हाँ हाँ, बोलिए, सही बोल रहे हो, बोलो. रैंडम क्यों बोल रहा है भाई? रैंडम पॉइंट अब जैसे मैंने वर्ड यूज ही नहीं किया है. मैंने सैंपल पॉइंट यूज किया है, सैंपल वैल्यू यूज किया है, या न्यूमेरिकल वैल्यू, या सैंपल फंक्शन यूज किया हुआ है. रैंडम पॉइंट कहाँ से आ गया एक नया वर्ड? सैंपल. हाँ बोलिए, सैंपल पॉइंट इसको नहीं बोलते हैं भाई मेरे. सैंपल पॉइंट सैंपल आउटकम को बोलते हैं. आउटकम सैंपल पॉइंट होता है. ये वैल्यू है, इसको क्या बोलते हो? कितने अच्छे से पढ़ाऊं भाई. ये देखो ना, सैंपल स्पेस, कैपिटल ओमेगा, आउटकम सैंपल पॉइंट, सैंपल वैल्यू स्मॉल एक्स, कैपिटल एक्स रैंडम वेरिएबल. अब इतना हिंट दे दिया मैंने. क्या है वो? What is this? Okay, वो वैल्यू क्या मिल रहा है आपको, ये तो बताओ। हाँ, अरे दादा, सबको समझ में आ रहा है कि क्या बोलना चाह रहा हूँ मैं? अभी तो नहीं समझा आपको? लेट मी ड्रॉ अ टेबल सो दैट इट माइट बी easier to you. So this is omega, this is T1, T2, T3, T4, T5, T6. This is head, this is tail. These are called as sample points or outcome. At T1, what is the value of this random process we started with? -4 and 2. At T2, it is -4 and 2. At T3, it's a -4 and 0. यही है ना, यही
सैंपल वैल्यू से
किया था ना मैंने स्टार्टिंग से। इतने देर में समझ में आ रहा है आपको? ये लिख रहा हूँ तब। हाँ, क्या है ये? इट्स a -6 1 and T5 is what? -2 2. पहले क्या किया हमने? टाइम को फिक्स किया। when I fix time, suppose T4 पे फिक्स किया, क्या मिल रहा है अपने को? random variable. say yes or no.
यस सर।
सो ये अगर रैंडम वेरिएबल है तो इसके सैंपल वैल्यू और न्यूमेरिकल वैल्यू क्या है? -6 और 1. yes or no? so these are small x, no? these are small x. these all are. when you fix omega, suppose you fix to omega like h, means you're talking about a particular waveform. Again set of values, but it is depending on the function of time t. But when you fix both, जो बोला हमने, कहाँ पे फिक्स कर रहे थे अपन? T2 पे फिक्स कर रहे थे। So T2 पे फिक्स किया मैंने पहले, फिर किस पे फिक्स किया मैंने? टेल्स पे फिक्स किया। So कौन सा कॉमन एरिया है? 2 मिल रहा है ना मेरे को? yes or no? yes or no? दिस इज सैंपल वैल्यू। क्या नहीं समझ में आ रहा है इसमें? बोलो। बहुत सिंपल तरीके से बता रहा मैं, इससे ज्यादा सिंपल नहीं हो सकता। तो दिस इज 2 फ्रॉम ग्राफ. This is called as sample value. So you get a particular value, a numerical value. These are the 4 definition of what? Random process. Let me go back to, let me give you that idea. What is this all about now? अभी इसका डेफिनेशन पढ़िए अच्छे से आप, तो आपको समझ में आएगा कि रैंडम प्रोसेस कैसे लिखा हुआ है, राइट? सो लेट मी जस्ट, अब इसको याद करने गए आप तो आप भूल जाओगे. यू कैन नॉट रिमेंबर इट, बट इफ यू रिमेंबर राम एंड साहिल यू विल नॉट फॉरगेट इट अगेन एनी टाइम. और इससे इजी तरीके से मैं नहीं पढ़ा सकता इसको, राइट? सो ये आपको सोचना पड़ेगा कि कैसे पढ़ना है. Now go to PPT and just see that one, how it is written, the definition of random process. अभी आप इतने आगे बढ़ गए हो, आपको रैंडम वेरिएबल का डेफिनेशन नहीं पता है, तो फिर कैसे करेंगे हम लोग? सी दिस, व्हाट्स रिटन हियर. स्लाइड नेक्स्ट करना होगा तो बोल देना जल्दी से, है ना? Tell me next slide, so I will slide this. I will what go to next page. Is this point clear in this slide? Yes. Yes, no?
Yes, sir.
Okay, good. Should I go to next page now? एक दो लोग अनम्यूट होके बैठ सकते हो ना? Should I go to next page?
Yes, sir.
Okay, so that is, I have explained here everything. So this is sample space. It contains capital M outcomes, sample points, omega 1, omega 2 up to omega m. It may be infinite outcomes also there. In that case, we are going to call it continuous sample space. It's basically discrete sample space that I have drawn. Omega 1, omega 2, omega m. These are called as sample points or outcomes. Correct? Should I go to next animation now? Say yes,
Yes,
or no.
sir.
Yes, sir. Yes, sir.
Each outcome, one waveform. Omega 1, x1t. Omega 2, x2t. Omega m, xmt. Now, one thing is to be clear, right? One thing you should make it clear that यहाँ पे मैंने 1 to 1 बनाया हुआ है. Like random variable, as I said that one, two outcomes may lead to same waveform. Is this point clear? जरूरी नहीं है कि आपके पास 10 आउटकम है तो 10 वेव फॉर्म होंगे, 10 आउटकम है तो 5 वेव फॉर्म भी हो सकता है एक ही वेव फॉर्म भी हो. Is this point clear?
Yes, sir.
Yes, sir.
So more than two outcomes may lead to single waveform, but one outcome cannot lead to two waveforms. Otherwise, it will be one to many function. That is not possible, right? Now, x1t, x2t, xmt, these are called as sample function, or you call it waveform, time function, right? Should I go to next animation?
Yes, sir.
Each one of these waveform is called as sample function, that is x1t, x2t, xmt. So this is definition of random process, ensemble or collection of all such sample functions. Go to next animation.
Yes, sir.
So this is what horizontal definition of random process. Now let's fix time. Let's sample the process at time t equal to t1. We call it sampling the random process at t equal to t1. What I get? These points, these values. x1 t1. This is x1t waveform. T equal to t1. It becomes x1 t1 a value. x2 t1 a value, another sample value. x3 t1 another. It's not x3 t. It is xmt. xm t1. Clear? So rest of the things are immaterial. If you fix the time t equal to t1, rest of the time are going to be unused. So this m outcomes will give you this m values. It may be one to many, sorry, many to one, but here I've drawn 1 to 1 random variable. Is this clear? Omega 1 is x1 t1 value, it's a value. Omega 2 x2 t1 value, and omega m, whenever omega m will come, I will map it to xm t1. So these are the sample values of random variable sampled the process at t equal to t1. Is this clear? Is this clear? Should I go to next?
Yes, sir.
This is the definition. X t sub k, random variable obtained by observing the process, observing or sampling. These are same thing. So these are terminology they use in book. Random variable obtained by observing the process at t equal to tk. Clear?
Yes, sir.
Sample it at some more instances. T equal to t2. I get x1 t1 t2, x2 t2, and this is not x3, it's a xm t2. For simplicity, I have just taken 1 to 1. Otherwise, it can be many to 1. This is another random variable at t equal to t2. So That is the next definition of random process. That is vertical definition. What is this? Collection of all such random variables indexed by time. Clear? Is this clear?
Yes, sir.
Good. Now read this definition. It is saying the same thing that I have said before, but it is more in formal letter. Just read it and tell me when I need to go to next slide. When you fix time, you get a sample function. Sorry, when you fix outcome, you get a sample function. Is this clear now?
Yes, sir.
ठीक है. Should I go to next slide now?
Yes.
Thank you for saying yes or no. Now see this second definition. So when you fix t, it is only going to be a function of omega. It means it is going to be random variable, because random variable is only function of omega. It does not include time. So notation is what? X, when you fix t equal to tk, omega, you call it xtk or you call it xk, where k is a time index. So k says the time. Definition 2. Is this clear?
Yes, sir.
Read the third point. When both omega and t are fixed, random process represent a particular numerical value or sample value. Right? Should I go to next?
Yes, sir.
Okay, good. Can you solve this problem? You just take a screenshot and find the answer later on. If you don't find it, I will explain it. Have you taken the screenshot? कर नहीं रहा मैं, नहीं कर सकता इतना मैं. हाँ बोलिए. Sorry, I was talking to Bhandekar sir. Have you taken the screenshot?
Yes, sir.
Now there is some classification of random process. So this is one classification, this is another classification, and this is the important classification that we are going to deal with. Right? You take the screenshot of this. It's very simple. When I say continuous random process, you just think like amplitude can take any value in that random process. Right? हमने पढ़ा है यहाँ पे continuous valued signal. Quantizer के पहले जो होता है वो क्या होता है? It can take any value, but after the quantization, it can take only value from a finite set of values. Am I correct? Yes. PCM का experiment किया है, PCM में theory पढ़ा है हमने. So continuous random process is a random process where random process can take any value, any value. So there are infinite set of possible values. What is discrete random process? Where the amplitude has to be discrete. Amplitude has to be discrete. Let me do this. Let me give you an example. Binary signal देखा है ना हमने? सुबह ही देखा हमने line code. Yes or no? Say yes or no. डिजिटल बाइनरी सिग्नल देखा है ना हमने, 0 1 1 0 1 0 0. So you draw it like 0, then 1, then 1, then 0, then 1, then 0, then 0. It can take only two values, either 0 volt or 5 volt. So source is random. Source is random, right? Source is random. So source is a random process basically, where it can take only two values, either 5 volt or 0 volt. So it means that when you know it may be 0 volt or it may be 5 volt, but you don't know at what time what voltage will come. Am I correct? Am I correct? Am I correct?
Yes, sir.
So this is called as discrete, you can call it discrete amplitude random process. But what if it is analog signal? Suppose I am speaking, you don't know next time what I am going to speak with what amplitude. Am I correct? So my voice signal look like this. This is my voice signal. So when I speak, when you are at this time, you don't know what is going, I'm going to speak at this time. Yes or no? But it can take any value, any value. Am I correct? Yes or no? But here it has to be always, it can be either 0 or 1. So you know that one, it can be either 0 volt or 5 volt. So there are finite set of amplitude. So it has finite amplitude labels. This is what, how many possible amplitudes are possible in this waveform? Yes. How many possible amplitudes are present in this waveform? Suppose this value is lying between
Infinite.
5 volts. So this is what infinite set of values, set of amplitudes. So this is called continuous amplitude random process. Right? When you sample this, this is time, no? When you sample this, what do you get? When you sample this process, what do you get? Is the time is continuous or discrete then? When you sample it regular interval, so it will be continuous time or discrete time then? Sampler का output क्या होता है? Discrete time or continuous time? अरे ये बाबा क्या बोलूं, समझ में नहीं आ रहा है क्या? When you sample it, what do you get?
Discrete time.
Discrete time, but amplitude remains what? Continuous. Yes or no? Yes or no?
Yes.
This is discrete time random process. You have discretizes the amplitude time now. What if you sample this? What do you get? 0 0 0 0 5 5 5 5 5 5 5 5 5 5 0 0 0 0 0 0 5 5 5 5 5 5 5 0 0 0 0 0 0. So this is 0 5 5 5 5 5 5 5 5 5 5 5 5. क्या बन गया ये? What is this? Discrete value, discrete time. So when you sample the discrete random process, you get discrete value, discrete time random process. Sometimes people call it, it's just a sequence. It's a waveform. It's a sequence, it's a waveform. It's a sequence, it's a waveform. Sequence, one after another. So sometimes people call it discrete value, discrete random process. Discrete sequence random process. Same here, continuous value, continuous amplitude, but random process, which is sequence one. Now go back to there. This is just, I said, digital, any source which is producing some signal. It is called continuous valued. This is called discrete valued. This is continuous random sequence. When I say random sequence, it's a time is what now discretized, or you can call it discrete time random process. This is a sampled version of continuous random process. So this is continuous valued, but now it is discretized. Now this is what discrete random sequence. Discrete means you are talking about amplitude. Sequence means you are talking about time discretization. So this is discrete value, discrete time. So when you quantize, you get discrete. So that's why you are calling it quantized version. Because if you remember, quantizer क्या कर रहा था वहाँ पे? Quantizer job was what? इसके इनपुट में क्या था? कितने वैल्यूज हो सकते हैं इसके इनपुट में? हो सकते हैं ऐसे? What is the output of quantizer here? Finite set of labels or values. यहाँ पे दो लिखा हुआ है, दो लिया हुआ है 05. I can have 8 quantization label. I have 16 quantization labels, but I know that one at the input of quantizer, value is changing from -2 to 2 volt. याद है? It can take any value between -2 to 2 volt. But at the output, it can take, if you take the step size, if you take 4 label quantizer, so you get step size कितना निकाला था हमने? If you remember 1 volt. So it can take only value -1.5, -0.5, 0.5 plus 1.5 volt. Do you remember? Do you remember? Do you remember these values? PCM में एक्सपेरिमेंट किया था हमने.
Yes, sir.
Yes, sir.
तो इसलिए मैंने बोला था जो क्वांटाइजर का इनपुट है वो कैसा है आपका? क्वांटाइजर का इनपुट इट्स अ कंटिन्यूअस वैल्यूड रैंडम प्रोसेस. बट क्वांटाइजर का जो आउटपुट है वो क्या है आपका? क्या है वो? डिस्क्रीट वैल्यूड रैंडम प्रोसेस. सो क्वांटाइजर के इनपुट को अपन कंटिन्यूअस वैल्यूड रैंडम प्रोसेस बोल रहे हैं और क्वांटाइजर का आउटपुट को अपन discrete value random process बोल रहे हैं, because we don't know which value is going to come, and according to the value it is going to map to which value we don't know. minus 1.7 आया, I will map it to -1.5, but I don't know which value is going to come. After coming I will know that was -1.7, but I don't know at the before that quantizer input will be what. I know the range -2 to 2 volt, but I don't know exactly what value the sample will take. The sample has. Is this clear now? Is this clear now?
Yes, sir.
This is what there. Depending on the sample function. Random process दो टाइप के होते हैं, एक deterministic होता है और एक non-deterministic होता है. One is deterministic and one is non-deterministic. Like the previous example. If head comes, xt will be sin 2t. If tail comes, xt will be 2t. Whenever you can write the waveform mathematically or in the tabular form, that you know what will be t equal to 0. So xt कितना होगा? You know that one. When you plug t equal to 0, you know what is xt. When t equal to 0, you know what is xt in this case. Am I correct? So if I give you what outcome is, you will give me, मैं पूछूंगा 1000 सेकेंड में क्या वैल्यू है. इफ हेड इज कमिंग, यू विल से सर दिस इज जस्ट sin 2 into 1000, sin of 2000. If I tell you, if I ask you what if tail comes, what is the value of your random process at t equal to 1000, you will say sir this is 2 into 1000, that is 2000. So whenever you will able to write any waveform mathematically, or I should say if this signal is deterministic, these waveforms are deterministic, so you know what is x1t, x2t, x3t, and all the waveforms, you know they are what? Deterministic. Then you call that process as what? Deterministic random process. Why still it is a random process? Because you don't know exactly which waveforms will appear. That is called what? deterministic random process. But if you don't know the outcome as well as the waveform, then you call it completely random process, and they are very difficult to analyze, like noise. Like noise. Is this clear? Is this clear?
Yes, sir.
So random processes are of two types. One is deterministic and one is non-deterministic. That's why I've written this is the classification based on the sample function. If the sample function is deterministic, I'm going to call it deterministic random process. If the sample function is non-deterministic, I'm going to call it non-deterministic random process. Or you can call it random process if you want to. This is what depending on the vertical and time, depending on the time and random variable, right? So you're talking about is random variable is continuous random variable or discrete random variable? Is this random variable is discrete time random variable or continuous time random variable? So here you're talking about random variable and time. Like quantizer, input was continuous random variable, output was discrete random variable. Like sampler input is what? Continuous random process. I can call it sampler. If you see sampler, its input is what? Continuous valued, continuous time. Sampler output is what? Continuous valued, but it's now discrete time. So this is what? This kind of sequence, continuous random sequence. So the source is continuous value, continuous time. So the source is what? Continuous random process. But the sampler output is value is continuous, but time is discretized. So that's why this is what? Continuous random sequence. Sequence means discrete time. You can call it discrete time random process. I hope this is clear. This third one is very important, which is what? Based on the statistical properties. Let me go back here and write that thing here. What do you do with this? When you say statistical properties, we are going to do two kind of analysis from the random process. Two kind of analysis. When you talk about vertically, there are two analysis, right? One is the what? Statistical analysis. And most of the time we are going to do statistical analysis only. And next is what? Time analysis. So you just tell me, statistical analysis I will do vertically or horizontally? You tell me, statistical analysis will involve random variable or time function? Yes, बोलिए. हाँ, बोलो भाई. Statistical analysis will involve random variables or time functions?
Time functions.
तो टाइम एनालिसिस क्या इन्वॉल्व करेगा? See this point table. You can take average here also like this. You can take average like this also. So this is called time average. And if you take average like this vertically, you call it statistical averages. So what is this? It is a statistical averages or time average if you go vertically. Statistical averages. So when you, since मैंने क्लास में भी बोला है, जब आपके रैंडम वेरिएबल होता है तो वहां पे भी एवरेज निकलता है, जिसको आप डिनोट करते हो किससे? एक्सपेक्टेशन ऑफ एक्स से. यस और नो? यस और नो? यस और नो? ये पढ़ा है ना हमने, मीन स्क्वायर वैल्यू निकाला था हमने किसका? यूनिफॉर्म रैंडम वेरिएबल क्वांटाइजेशन नॉइज का, डेल स्क्वायर बाय 12. Yes or no? But when you see this as xt, how to find average DC value? What do? Limit t tends to infinity 1 upon t. ये गर्विता ने क्वेश्चन पूछा था. This is called what? What is this? This is average, no? ये किसके ऊपर एवरेज हो रहा है? टाइम के ऊपर या वैल्यू के ऊपर? टाइम, राइट? अभी मैं पूछता हूँ कि आपका हेड की प्रोबेबिलिटी हाफ है, टेल की प्रोबेबिलिटी हाफ है. यू टेल मी एट T1 व्हाट इज द एवरेज वैल्यू? व्हाट डू यू से? See this point carefully, right? Just take this point now and what I'm writing here. Let me frame the two questions here. What is the average value of this random process? Let's say this random process, right? So let me just write this is let me call it table 1. Average value of table 1 when T1 is when T equal to T1, when T equal to T1, right? See the point, see this carefully. Provided probability of head is 1/3, probability of tail is 2. क्या आएगा? So you are talking about what? T1 जब फिक्स किया तो आपको क्या मिल रहा है? ये -4 और टेल क्या मिल रहा है आपको? 2 मिल रहा है. So ये बोल रहा है अभी हेड है -4, टेल है 2 है. You tell me the average value of this. What I am going to expect from this experiment, right? At T equal to T1. On an average, what its value is? What is the answer? Since you are saying that one head comes with probability of 1/3, so when head will come, it will come with -4 rupees. When tail will come, sorry, this is not 1/3, this is 2/3. This is not 2, this is 2/3. Probability has to be 1, right? And when tail comes, the probability has to be 2/3 and it will come with 2 rupees. Is it not average? Is it not average? Is it not average? Okay, just throw me out this point. Just see this. आपने इसको बहुत बड़ा चीज समझ लिया, इसलिए आपको समझ में नहीं आता है. ये समझ में आ रहा है? Suppose you play a game. Suppose you play a game millions of times. And let's say 1,000 times. Let's give me the number 1,000 times. And out of 1,000 times, so 100 out of 1,000 time, you get 5 rupees. Out of 1,000 times, suppose 300 times. Just wait a minute, I got a call. हाँ नहीं मैम नहीं चाहिए. So suppose 300 out of 1,000 times I get 2 rupees, and 400 times out of 1,000 times I lose, that you lose or you get -1 rupees. So it means you lose 1 rupees, so you get -1 rupees. कितना हो गया? 4 3 7 8. Let's just 200. So 200 out of 1,000 times you get suppose 4 rupees. Is this question clear to everybody? Is this question clear to everybody? Is this problem is clear, this statement? Say yes or no.
Yes, sir.
Okay, so see the question now. The question is as follows. If you play the game, same game, next time, on an average, how much money you will earn? How much money you will earn? Yes, can you answer this question? This is nothing to do with the theory and all these things, mathematics and all those things. It is just a question imposed on you, like day-to-day life question. Yes, तभी तो मैं next time जाके गेम खेलूंगा ना. I have some past experience with that game. नेक्स्ट टाइम वो गेम खेलूँ या नहीं खेलूँ, वो इस पर डिपेंड करेगा कि एवरेज में माइनस में जा रहा हूँ या प्लस में जा रहा हूँ और कितना जा रहा हूँ प्लस में. सो आई विल डिसाइड शुड आई प्ले द गेम और नॉट. Yes, tell me. How will you get this answer? Can you tell me that? Yes. कोई बता सकता है कैसे करेंगे सॉल्व इसको? The question is something what it is asking me expectation of x. This is called average value. This is the question of expectation of x. This is a statistical average. It has nothing to do with time. बोलिए. Yes. Can anybody answer this question? Say something. Huh? Say something. नहीं आता है बोलिए. आता है तो आता है बोलिए. Say something. Don't calculate. I'm just asking you. Can you solve this problem or not? Can you solve this problem or not? Yes, don't hesitate to answer, right? नहीं आता है तो नहीं आता है, आता है तो आता है बोलिए. अरे बोलो भाई कुछ, मैं अपना टाइम वेस्ट कर रहा हूँ यहाँ पे, ऐसा हो जाएगा. Say something.
सर नहीं आ रहा है.
नहीं आ रहा है तो बोलो ना भाई. हाँ ठीक है, अभी सुनिए मैं कैसे कैसे बोल रहा हूँ, राइट? मैं वर्ड पे ही सॉल्व करूंगा इस प्रॉब्लम को, ठीक है? जस्ट सी दिस. ये क्वेश्चन समझ में आया क्या? लेकिन नहीं तो डू यू गेट द क्वेश्चन?
यस सर.
सॉल्यूशन समझ में नहीं आ रहा अपने को, राइट? दैट इज द ओनली थिंग.
यस सर. हाँ, सॉल्यूशन नहीं समझ नहीं आ रहा.
ओके, गुड, थैंक यू. सो just think this question. This is just a question on expectation, average. How much I will expect if I play the next game. That's why the name is expectation, right? Now see this question. 5 rupees this expectation is nothing but 5 rupees I will get 100 out of 1000 times. So if I play the game, it will be chances that 100 out of 1000 times I will get 5 rupees. Yes or no?
Yes, sir.
Okay. 2 rupees I will get 300 times out of 1000 times. Is this clear?
Yes, sir.
Yes, sir.
Can you get the answer? Next two terms. -1 into 400 upon 1000. If I play the game, I will have chance to get 4 rupees 200 times out of 1000 times. Is this clear?
Yes, sir.
You tell me, is it that much difficult? If you think this thing in like this, in these terms. बोलिए, बोलो भाई. सोल्यूशन समझ में आया? सोल्यूशन दे दिया मैंने आपको.
Yes, sir. Yes, समझा.
राइट. इट्स वेरी वेरी इजी. एक्सपेक्टेशन का फॉर्मूला ऐसे ही नहीं आया. एक्सपेक्टेशन का फॉर्मूला पढ़ते हैं आपने. किसी ने याद है किसी को ये फॉर्मूला? पता नहीं कितने लोगों को याद होगा, बट यू डू लाइक दिस वन. हैव यू रिमेंबर दिस फॉर्मूला? ये मैंने भी क्लास में बात किया है. डू यू रिमेंबर दिस फॉर्मूला? Sum x px x. What you did just here. Can you tell me what is the probability of getting 5 rupees? What is the probability of getting 5 rupees?
100 upon 1000.
Thank you. This is the probability of getting. This is nothing but probability of getting 5 rupees. This is nothing but probability of getting 300 rupees. What you are doing? Probability of getting 2 rupees, you are multiplying with 2. Probability of getting 5 rupees, you are multiplying with 5. Probability of getting -1 rupees, you are multiplying with -1. Probability of getting 4 rupees, you are multiplying with 4. Is this formula? It should be the formula. Should this be the formula or not to get the expectation? Should it be the formula to get the expectation? Yes or no?
Yes, sir.
Yes, sir.
हम इसको अभी तक से याद करते आ रहे हैं, इसलिए भूल गए हम लोग. If you remember this thing, you can derive the formula for expectation of x. Just see this. This is called PDF, or it is discrete one. That's why you call it PMF. Let me go and check that. -1 somewhere here, then I will get 2, so somewhere here, then I will get somewhat 4, so somewhere here, 5 is somewhere here. This is nothing but small x, and we draw the probability of -1. How much it is? 400 by 1000. So this is 400 by 1000. What is probability of 2 rupees? It's a 300 by 1000. What is 4? Is 200 by 1000. What is 5 rupees probability? It's 100 by 1000. What is this? This is a probability distribution among the value. So it's a plotted with respect to x. This is called what? PMF. PMF, probability mass function. This is discrete random variable because it can take -1, 2, 4 or 5. Continuous random variable, how do it look like? So this is x. So it will look like PDF, continuous. It may be from -1 to 5, but the outcome can take any value between -1 to 5. This is called as PDF, probability density function. it is just a probability. You can see 300 by 1000, it's a probability, but PDF is not probability, it's a density, probability density. It also gives you the distribution of the value, probability distribution for the value. It may lie between -1 to 5, but it's a density function. So this is continuous random variable. We characterize it by PDF, and this is discrete random variable. We characterize it by PMF. So इसलिए नोटेशन इसको मैंने P ही रखा है, यहाँ पे मैंने इसको F कर दिया है. बुक्स में they don't differentiate this two. चाहे वो कंटिन्यूस हो चाहे डिस्क्रीट हो, they write small p or they write small f. एंड सिग्नल सिस्टम में भी शायद से आपने स्मॉल f ही पढ़ा है. You did not read it for p. This is the formula. This is formula for discrete random variable. But what if I have continuous random variable? This should be expectation of x. Sum, discrete में sum है तो continuous में क्या होगा? बोलिए. डिस्क्रीट में सम है तो कंटिन्यूस में क्या होगा?
Integration.
Yes, this will be expectation. यहाँ पे ये -1 to 5 है, but it can be -infinity to +infinity, so I will write -infinity to +infinity x fx x dx. This is the PDF. This is the expectation if you have a discontinuous random variable. You just read about discrete, you generalize it for continuous. But don't get confused. This fx(x) is not probability. It's a probability density function. How much dense the probability is. This is discrete. If you want to make also this PDF, then you have to use impulses. If you write impulses, no, don't write PMF, you write PDF. So books वाले क्या करते हैं? Communication signal system वाले, they show it by impulse and they say we don't have PMF kind of thing, we just have PDF kind of thing. Right? And they say the area under probability is what? They say, suppose you want to find what is the probability of getting 2 rupees? It's a 300 by 1000. But here, what is the probability of getting 2 rupees? You will say this is 0 because area under probability is going to be just a line. So it will be 0. So PDF is not probability, right? PDF is not probability, but PMF is probability. But you find the area of impulse. What do you get? 1. So this will be 300 by 1000 because impulse only exists at 2. When you integrate this PDF, you will get 300 by 1000, right? So they say it's a PDF. This is also PDF, but they don't show bar graph. They show impulses. But I want to distinguish it. I'm not a communication engineer for the time being, so I will just do it like this. So at the beginning, we always should say this is PMF and this is PDF. And we should not mix up these two things. We should not mix up these two things, right? Is this clear now? What the x-axis is? This is not time axis. This is x-axis. So you are averaging over the values. You are not averaging over the time. You are not averaging over the. It is what this limit is. It is averaging over the values. Yes or no? Yes or no? Yes or no? Say something.
Yes, sir.
Okay, good. Now, let me give you another problem so that it will be clear for time average. Suppose you have a shape like this. Let me take just the known one. We know it, right? It's a sine wave. What is its value? DC value? What is its DC value? Huh? What is its DC value? So DC value कितना होता है साइन वेव का? It's a T naught. अरे भूल गए क्या? इसका DC वैल्यू कितना है? इसका DC वैल्यू कितना है? इसका एवरेज वैल्यू कितना है?
0.
तो DC वैल्यू और एवरेज वैल्यू कोई अलग अलग चीजें हैं क्या? These all things are same, but they are time averages. These parameters are time averages because we are averaging over time. So you say sometimes it's plus, sometimes it's minus, but you are saying that when the times you are getting plus, the same times you are getting minus, so on an average you are 0. This is the same question that I am asking. I am asking, this is a waveform, tell me on an average इसकी value कितनी है. So you will say, sir, 50% chances that you are positive, 50% chances you are negative of the time, total time. So on an average you are 0. So I am 0, right? Yes or no? And you are
Yes,
0.
sir.
Yes, sir.
So that is the same question I am asking here. But here the definition is what? The definition is what? You need to find the area. Average निकालना है ना मेरे को. So average हमेशा कुछ divided by होना चाहिए. So ये area निकलेगा यहाँ पे और टाइम से डिवाइड करना है क्योंकि ये इन्फिनिटी टाइम्स आई कैन नॉट एवरेज ओवर इन माइनस इन्फिनिटी प्लस इन्फिनिटी बिकॉज इट विल बी अदरवाइज इन्फिनिटी आई हैव टू डिवाइड बाय इन्फिनिटी व्हिच इज नॉट पॉसिबल. सो व्हाट I do what? I take a very large time t and I integrate it. So this is called area. So you get the area and divide by the total time, you get average. And let this limit t goes to infinity because I cannot put t equal to infinity directly. So I have to give the answer in terms of what? Limiting average. So these are limiting averages. These are limiting averages because you are talking about averaging over all the time from minus infinity to plus infinity. So this is time average. This is time average. And this is what? Statistical averages. Time average. This is one of the time average. It's not only one time average. Let me talk about this power. Power के लिए क्या करते हो आप? It's 1 upon t minus t half to plus t half x square t dt. You do it or not? Yes or no? Yes or no?
Yes, sir.
So again you are doing what? You can just think this x square t is nothing but again a function of t, which is nothing but, let me call it yt. So what it becomes? It's the average value of yt. Can I call it with the same definition of this? Yes or no? Say yes or no. बोलिए भाई. It's the average value of xt. Can I call it average value of yt, where yt is equal to x square t? Yes or no? This x square t I am writing as a yt. If you square it, it becomes a new function. I am calling it yt. Yes or no?
Yes, sir.
So I can call it average value of x square t, or I can call it what? It's a mean square value of xt. See this point. This is average value of x square t, but with respect to xt, it's a mean square value of xt because you first squaring it and then finding the mean. You are squaring it, then finding the mean. You are squaring this xt and then finding the average. That's why you're calling it mean square value of xt. But you can call it average value of x square t. Can I not? This will be average. I don't know. I don't know the name of this average, but I can create my own average. Is it not average? Is it not an average? Yes or no? Yes or no? What is the average of, can I call it? It's the average value of x cube t. Can I call it? Yes or no?
Yes, sir.
So if I ask you how many time averages are there in the world, what do you say? How many time averages are there in the world?
Infinite.
Infinite. You don't have to think so much, right? यहाँ पे हमने बोला है कि भाई अब हमारी हालत खराब हो जाती है एक्स टी को इंटीग्रेट करने में, हम एक्स स्क्वायर टी का इंटीग्रेट करके दिखा रहे हैं, आप बात कर रहे हैं एक्स क्यूब का, तो लोग जाना नहीं चाहते वहाँ पे, एंड दे डोंट डू सच काइंड ऑफ एनालिसिस. दिस आर वेरी रेयरली analyzed values, but this is also average value because you are dividing by t and you are integrating it. Area divided by t always will be statistical averages. What about energy? Energy is just x square t. Is it average? It's a time property, but is it a average? Is it average? Is it average? Energy, is it average?
No, sir.
No, it's not a time average, because you are not averaging it over time. Other thing, whenever you divide by t, it's average, it's a time average. So there are infinite possible time averages. You can have so many integration density, but time averages give very, very important role. DC value, power, everything. Same here. Why I don't have some denominator over here 1 over something, like here 1 over t I have, but I don't have here 1 over something, because this probability is already normalized. Can you see that? It is already divided by 1000. इसको एवरेज किस में कर रहे हो आप? 1000 आउट ऑफ 1000 टाइम्स एवरेज कर रहे हो. यस और नो? यस और नो?
Yes, sir.
That's why in this kind of thing you don't have 1 over something here, but you call it statistical average, because this pxx or fxx is, it's already normalized one. It's already divided by some value, this 1000 times. Are you getting my point? Are you getting my point?
Yes, sir.
Okay. So there are infinite statistical properties. There are what? Infinite time averages. So when I talk about this one, I am talking about what? Averaging over the values vertically, averaging over the values, averaging over the values. It does not have to do with any, when you fix the time, so at T1 average may be different, at T2 average may be different, at T3 average, statistical average may be different. But if I say at all time, all the statistical averages are same, that process is called as stationary process. Are you getting my point? Are you getting my point?
Yes, sir.
Are you getting my point? So how many statistical averages are there? You fix T1 and find the statistical averages. I will find xt1, expectation of xt1. I can find xt1 square t. This is also a statistical average. I will find x cube t1. I can find log of x t1. If it is positive, let me take mod. I can find expectation of, I can form any function of xt and call it average. Yes or no? Yes or no? Because there are infinite averages. Yes or no?
Yes, sir.
So then the same thing you do with T2, you find all these things. And if this thing is same as this one, expectation of xt2, and this xt1 mean square value, it's same as this one, and this xt cube, it is also same as this one, this is T2. And for all time you do this, if all these statistical values are same, if all the statistical values are same, they do not change with time, means that process is called a stationary process. That process is called what? A stationary process. So that is dependent on the statistical properties. So that's why I said that when you do statistical analysis, you work on vertically. When you do time analysis, you work on horizontally. And when this statistical properties like DC value you find here, in this case, same DC value if you get in time also, and this statistical averages are equal to time averages, you call it ergodic process. You call it what? Ergodic process. What I said now? If statistical properties do not change, don't change with time, we call it what? Stationary random process. This is very, 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 very strict condition. इतना स्ट्रिक्ट कंडीशन कोई भी रैंडम प्रोसेस फॉलो नहीं करता है. आर यू गेटिंग माय पॉइंट? आप बोल रहे हो कि एक्सपेक्टेशन ऑफ xt1 निकाल, फिर एक्सपेक्टेशन ऑफ xt2 निकाल, फिर एक्सपेक्टेशन ऑफ xt3 निकाल, ये सब के सब सेम होने चाहिए. फिर आप बोल रहे हो कि कोई भी फंक्शन बना दो xt का, कोई भी फंक्शन बना दो रैंडम वेरिएबल का, xt1 स्क्वायर कर दीजिए, xt1 इंटू xt, यहाँ तो ये भी यही बात किया हमने, बट ये भी है यहाँ पे एक्सपेक्टेशन ऑफ xt1 टाइम एक्सपेक्टेशन ऑफ xt2, it should be equal to expectation of xt2 into expectation of xt3. If the difference between these two is same, right? T2 minus T1 should be tau and T3 minus T1 should be tau. So I'm saying that when there is no change, if you take two random variables separated by same time, then their statistical properties should not change. I mean, this is what two random variables we are taking at a time now. So this is very restricted condition. No random process follow this property, and that process is called stationary random process. And यहाँ तो छोड़ दीजिए, अभी आप एर्गोटिक में बात करिए. वो क्या बोलता है भाई? Statistical properties, all the statistical means all the मतलब infinite statistical properties or statistical averages. Let me write averages. क्या कर रहा मैं? All the statistical averages are equal to time averages. Means horizontally आप average निकालिए, vertically average निकालिए, और ये सब के सब बराबर है. Then we call that process as what? Ergodic process. ये तो और डेंजर है. It is asking me what vertically भी जो averages आ रहे हैं और वो वही averages अगर आप टाइम पे निकाल रहे हैं, वो दोनों क्या आने चाहिए बोल रहे हैं आप? सेम आने चाहिए. It is more स्टेट कंडीशन. ये तो पहले ही स्टेट कंडीशन था, अभी और ये स्टेट कंडीशन हो गया. सो वी क्लासिफाई द प्रोसेस, रैंडम प्रोसेस बेस्ड ऑन देयर स्टैटिस्टिकल प्रॉपर्टीज एंड ऑल. So the process in which statistical properties do not change with time, we call this as a stationary process. Don't think stationary is just the random process has stopped. It's like a steady state. You fill a tank और उस टैंक के नीचे से एक साइड से एक वो कर दीजिए, होल कर दीजिए. थोड़ी देर बाद देखोगे कि आप टैंक में पानी उतना ही का उतना ही है. तो इसका मतलब ये नहीं कि प्रोसेस स्टॉप हो गया है. प्रोसेस इज स्टिल रनिंग बट इट इज इन स्टेडी स्टेट कंडीशन. So stationary is something what? Steady state condition. Are you getting my point? Are you getting my point? Are you getting this point? Are you getting this point?
Yes, sir.
So
Yes,
टाइम के साथ ये रैंडम प्रोसेस खत्म नहीं हुआ है, टाइम के साथ चल ही रहा है. बट वहाँ पे जो प्रॉपर्टीज हैं आप देखे होंगे कि अब मैं 10 दिन के बाद निकालूं उस रैंडम प्रोसेस का स्टैटिस्टिकल एवरेजेस और आज निकालूं, वो दोनों के दोनों सेम है. मतलब that random process is what? Stationary process. It's a steady state random process, right? And ergodic process is more than this. He's saying that one भाई statistical averages time averages के equal होना चाहिए, right? ठीक है. So we will stop the lecture now. Go and just I will share this PDF with you. Just somebody just send me what I think in T7 I have uploaded this PDF. Have you seen that one? Hello? Yes.
सर T7 वाले टीम पे देखा नहीं, देख लेते हैं.
हाँ देख लो, वहाँ पे PDF CDF के बारे में दिया हुआ है तो प्री
सर
रिक्विजिट
क्लास नोटबुक्स में रहेगा या फाइल्स अपलोडेड में रहेगा?
फाइल्स में रहेगा. वो दो नोट्स हैं, यूनिट 3 प्री रिक्विजिट और यूनिट 3 करके. If you have my number, you just WhatsApp me so that I will tell you what you need to do before coming to the next class, right?
Yes, sir.
So you just send me an WhatsApp message to me. I will tell you what you need to do next time. But otherwise, I cannot do whole things in the class. Correct?